All right, so this is our sample final C. And in terms of questions, I believe it's the same format. We have 21 questions, just a bunch of parts. Yeah. A lot of pages. But okay, let's get into it. Question 1. We have let f of x equal x minus 8 and g of x is equal to x squared minus 4x plus 11. We want to find f times g of x. This is not an open circle. If it was an open circle, we're dealing with what's known as composition of functions. This is just an operation. This is multiplication. So essentially, we're just multiplying our f, our x minus 8, by our blue, x squared minus 4x plus 11. Use parentheses here. X minus 8 times x squared minus 4x plus 11. And we're going to utilize some special distributive property. X times x squared gives us x cubed. X times negative 4x gives you negative 4x squared. And then x times 11 gives you plus 11x. Then negative 8 times x squared gives you negative 8x squared. Negative 8 times negative 4x gives you a positive, 32x. And negative 8 times positive 11 gives you a negative 88. We're not done because we can combine some like terms. So the x to the third just stays down, but we have negative 4x squared and negative 8x squared, which gives us what? Yeah. And then we have a positive 11x and a positive 32 gives us, right? And then we have minus 88. So what we have boxed is our final result in simplified form. Okay. Good. Right, let's move on. Question 2, we are asked to evaluate this expression, and they give us our x, y, and z values. So I think what I'll do is I'll color code them here, and then that way we can just jump straight into substituting. Okay. So now when we substitute it in, we get 1 times negative 1 times 1. For our numerator, our denominator, we get 1 squared plus negative 1 squared plus 1 squared. This is all inside an absolute value, and a negative is on the outside. Let's simplify the numerator. That just becomes negative 1. The denominator, we have 1 squared, which is 1, negative 1 squared, 1, and 1 squared is 1. So yeah, we get 3. And then what's the absolute value of negative 1/3? Positive 1/3, and then we're multiplying it by a negative, so you got it. Go ahead and move on to question 3, which is a long division problem. So let's set it up properly. We have are 3x cubed plus 9x squared minus 5x minus 1. Do we need to put in any placeholders? No, we're good. Okay. And then our divisor we have as x plus 4. They're explicitly stating to use long division. So if you use synthetic, only use that to check, but you need to solve using long division to get full credit for this problem. X times what gives us 3x cubed? Good. Now let's take the product and we end up with 3x cubed plus 12x squared. We are going to subtract this, and if we did it correctly, that first term will cancel out. Now we're looking at 9x squared minus 12x squared, which gives you a negative 3x squared. And then we're going to go ahead and bring down the negative 5x and the negative 1 and repeat the process. So x times what gives you negative 3x squared? Negative 3x, take the product, we get negative 3x squared minus 12x. Subtracting this, first term cancels out once again. And now we're looking at negative 5x plus 12x, which gives us a positive 7x. Bring down the negative 1. Repeat the process. X times what gives you 7x? Yeah. Take the product, we get 7x plus 28. Subtract, first term cancels out. Negative 1 minus 28 gives you a remainder of negative 29. Now they're explicitly asking us to find the quotient, so we do not include our remainder. We are just including what we have in pink for our final results. So we get 3x squared minus 3x plus 7, and we're done. Right. Go ahead and move on to question 4, which is asking us to factor the expression completely. Now, anytime it's asking you to factor, your first thing that should pop into your head is, can I pull out a? Good. Can I pull out a GCF, a greatest common factor? And can we here? Yeah, we can. Our GCF is 3x. So when we pull out 3x, what are we left with in parentheses? X squared minus 9, which is a sum and difference formula that can be broken up into x plus 3, x minus 3. And now is it fully factored? It is indeed, so we have our answer. Okay. Good. All right, let's continue. Page 3. We have solved the equation 4x. Anytime you're given a question where it's like solve the equation, you want to figure out, okay, well, what variable are we solving for? We're solving for x, which means we want to get x all alone. That's our objective. Get x all alone. Isolate it. So how do you think we're going to have to go about doing that? Well, I can make 2 a fraction, 2 over 1, and then I can jump straight into the whole butterfly method of cross multiplication. So we're looking at ax plus b times 1. That's just ax plus b. is equal to 2 times cx plus d. We don't have any more fractions. Becomes slightly easier. And we eventually want to get all of the x's to one side, so I'm going to have to utilize some distributive property on that right-hand side to get 2cx plus 2d. So we no longer have parentheses. And again, get all of the x's on one side. So let's first bring our green boxed terms to one side. And then we can bring our orange boxed terms to the other side that don't have any x. And so how we're going to do that, we're going to subtract 2cx from both sides. And then we're going to subtract b from both sides. So we're looking at ax minus 2cx is equal to 2d minus b. And now that the x terms are all on the same side, what can we do? We can factor out the x. So when we factor out the x, we're left inside the parentheses a minus 2c. And then that right-hand side can just stay as is. And then our very last step would be what? Yeah, we're going to move everything except the x over to the right-hand side. And because it's multiplication, we're going to divide both sides by a minus 2c. And so we end up with our x is equal to 2d minus b all over a minus 2c. And that's it. Yes.
Would you dividing, if you, instead of just factoring it, you just divided a minus 2c from both?
Yeah. Mm-hmm. A minus, you're saying,
Just
so starting from up here, instead of the cross multiplication, if you divided both sides by ax plus b, you can multiply both sides by cx plus d, or you can divide both sides by ax plus b, but you can't just divide these terms separately. Yeah, because it's separated by a plus, you have to treat it as the binomial as a whole. Yeah. Mm-hmm. Any other questions? No. All right. Let's move on to question 6. We have solved the linear equation for x. Ooh. And isolate x again. Here we're going to have to look and identify a least common denominator. What do you think our LCD is going to be? Yeah. So 3x as a fraction is 3x over 1. And yeah, let me rewrite it all out here, and I'll just create some space in between so that we can get each fraction to be a denominator of 6. So that first fraction we're going to multiply by 6 over 6. The second one, 3 over 3. The third one, 2 over 2. And the last one, 1 over 1 or nothing, right? So we get 18x minus 15x all over 6. since the denominators are the same. And then 2 in parentheses, x plus 1 minus 1 all over 6. And now that the denominators on the left and the right-hand side are 6, we can multiply the entire equation by 6 and just look at the numerators. So we have 18x minus 15x, which we'll reduce in a moment. Let's use distributive property here, is equal to 2x plus 2 minus 1. What's 18x minus 15x? Yeah. What's 2 minus 1? 1. Let's subtract 2x from both sides. Continue to combine some like terms. Oh, and it works out so nicely. We get x is equal to 1. And we're done. Now, something to keep in mind for a question like this, if the denominator was like a binomial, like x minus 6, we would need to write off to the side that x could not be equal to 6. And that's because then the denominator would be 0. So I think there was a question like that on a past exam or sample exam. So I'm just stating it now just in case. Let's move on to page 4, question 7. We have, if the length of the legs of a right triangle are 2 and 2 square root of 3, use the Pythagorean theorem to find the length of the hypotenuse. What's our Pythagorean theorem? Good. We're always referring to right triangles when we are using our Pythagorean theorem. Our hypotenuse is always our C, and our legs can be interchangeable. So we're going to have A be equal to 2 and B be equal to 2 square root of 3. You might be able to easily identify that we have a 30, 60, 90 degree proportionality. And then we end up getting 4 to be the hypotenuse. But if you didn't pick up on that, it's okay. We can just plug it into our theorem, and then we'll solve it that way as well. So essentially, we're just solving for C. 2 squared is 4. 2 square root of 3 squared is the same as 4 times 3. 4 times 3 is 12. And 4 plus 12 is 16. And what's the square root of 16? Yeah, which is exactly what we said about 30 seconds ago. So C is equal to 4, which is our length of our hypotenuse. Let's move on to question 8. Most likely have a question like this on the final for sure. They love these types of questions. I know, that's I think why they like it, because it really tests your ability of working with fractions, using your operations of division and multiplying fractions. So keep, change, flip for division. Teaches you or enforces your knowledge of factoring, your sum and difference formulas, your AC method. There's a lot that is evaluated in a question like this. So we have division, we have multiplication. Multiplication, straight through. Division, you end up flipping. Let's first start off with pulling out a GCF or identifying some special factor formulas. So maybe like sum and difference. I see a sum and difference here. I see another sum and difference over here. I see a GCF I could pull out over here. And then we can find factor pairs of 64 that add to negative 16. We can find factor pairs of 35 that add to 12. Right, so let's do it. The yellow can be broken up into x was the square root of 49. Yeah, plus 7, x minus 7. What about the orange? X plus, yep, x minus 8. What's the GCF we can pull out for our green? Yeah, and when we do, what are we left with? Yep, and we have an x plus 8 just chilling down there. And this is divided, right? And then what about our blue? What are factor pairs of 64 that add to negative 16? Yeah, negative 8 and negative 8. What are factor pairs of 35 that add to positive 12? Yeah, 7 and 5. Good. So because this guy is being divided, we keep this first fraction the same. We change the division to now multiplication. And then we flip this guy. So now our x plus 8 is in the numerator. And then our 2x minus 7 is in our denominator. And then this is all multiplication, so we can just bring that down. So now, since all operations are multiplication, we can just put the numerators all together and the denominators all together as one giant fraction. Again, you're just multiplying. And we can do a lot of cancellation at this point. If you see an x plus 8 in the numerator and an x plus 8 in the denominator, cancel it out. If you see an x minus 8 in the numerator and in the denominator, cancel it out. An x plus 7 in the numerator and the denominator, cancel it out. An x minus 7 in the numerator and the denominator, cancel it out. And then what are we left with? We only have x minus 8 left in the numerator. And then in the denominator, we're left with a 2 and an x plus 5. So you can either write your answer as just x minus 8 over 2x plus 5, or if you wanted to distribute that 2, you can write it as x minus 8 over 2x plus 10. Either of these would yield you full credit. And that's it. Right. So it's less daunting when you break it up into steps. Factor out anything you can first, manipulate the operations, and then cancel out the repeated binomials. And then you're left to something that's very, very straightforward. Questions? Feeling good? Okay. Again, I'm recording this so you can watch it later. You can fast forward, rewind at your leisure. Okay, question 9. We have solved the absolute value equation. We're given 3x plus 2 minus 5 is equal to 4. We want to find our solutions for x. So anytime you're dealing with absolute value, you want to get the absolute value all by itself first. So we're going to add 5 to both sides, and then we're going to go ahead and divide both sides by 3. And then we can jump into our positive and negative cases. Because with absolute value, we have our 2 separate cases. And the definition of absolute value is distance away from 0, and distance is always positive. So the positive case is we just drop the absolute value and we could solve. The negative case is the same as the positive, but the only added feature is that right-hand side is being multiplied by a -1. And now let's solve. We're going to subtract 2 from both sides in both cases, right? Work it simultaneously to save time. And so you get x is equal to 1 for the positive case and x is equal to -5 for the negative case. And our very last step is we need to check to see if both of these solutions work. So let's first plug in 1. 1 plus 2 is 3. Absolute value of 3 is 3. Times 3 is 9. 9 minus 5, does that give you 4? It does indeed. Now let's plug in -5. -5 plus 2, -3. Absolute value, +3 times 3. 9 minus 5 also once again gives you 4. So we have 2 solutions here. In ascending order, we have -5 and +1. And that's it. Move on to question 10, where it's asking us to find the domain of the function and to write our answer in interval notation. So anytime you're dealing with domain, we have 2 conditions that we want to look at. First condition is denominator cannot be equal to 0. And then the second condition is we have no negative number under an even root. Okay. Lucky for us, we have no roots here. We just have a denominator. So we can cross out that second condition. It doesn't apply here, and just hone in on that first one by looking at the denominator and making sure that it doesn't equal 0. So x squared plus 7x plus 12 can't equal 0. We can factor that left-hand side. Factor pairs of 12 that add to 7. Yeah, 4 and 3. And so by 0 product property, our x can't be equal to, yeah, in ascending order, we'll do -4 and -3. And so if these are our only restrictions, from a number line perspective, if we're looking at -infinity up to +infinity, the only values that are not included in our domain are at -4 and -3. Those are our open circles, but everything else is included. So how would we write this in interval notation? Read the number line left to right, and we get -infinity, comma, -4, soft bracket, because it's an open circle, union, soft bracket, all values between -4 and -3. And then our last union, -3, all the way up to infinity. A lot of students forget this middle portion. That's it. Yeah.
I think you're right. Negative infinity and then comma infinity.
Why can't you write it as negative infinity, comma infinity? Because we're not including these two values. Yeah. Negative infinity, comma infinity includes all values, but -4 and -3 are the only values not included. And these soft brackets state that, okay, -4 isn't in our solution and neither is -3. But every other number, -3.111111 is, -4.99999 is, but -4 isn't, and neither is -3. Yeah. Okay. Let's move to question 11, where we have a rational inequality question. This is good practice from the quiz that we took earlier today. And so we have everything over on that left-hand side, and our right-hand side is 0. So we're good with that first step. Our second step is we want to find our critical values. And remember, critical values are values that make it undefined and 0. So we have a fraction here, which tells us that when x is equal to 5, it's undefined. And if it's undefined, are we going to have an open or closed circle? Yeah, it's always open for undefined. And then what makes the fraction 0? When x is equal to? Yeah. And is this open or closed circle? Yeah, it's open because we're looking at just less than, not less than or equal to. Now we're ready to make our number line. We're going to put in our critical values. We have -2 here, we have +5 here, and we know that both of them are going to be open circles. Now a value that is less than -2, -3. So we plug in -3, -3 plus 2 is a negative. -3 minus 5 is a negative, and a negative divided by a negative is a positive. What's a value between -2 and 5? 0. We plug in 0 and we get 0 plus 2 is positive. 0 minus 5 is a negative. A positive divided by a negative is negative. What's a value greater than 5? 6. 6 plus 2 is a positive. 6 minus 5 is a positive. A positive divided by a positive is and so now we're looking once again at this inequality. It's less than 0, so we're looking at our negative. So our final answer is, yeah, that's it. Ten more questions left. Over halfway done. Question 12 is another inequality question. And we're dealing with that word and. You guys remember the difference between and or? And less than. That stands for all values that are shared, the overlap between your inequalities. So all values shared, aka the overlap. Whereas or just talks about everything. If you have or, you're just including all solutions from both inequalities. So we solve the inequalities separately first, and then we put them both on the number line, see the overlap, and then draw that additional number line to just show the overlap, the shared values. Okay. You want to get x's all alone in both of these cases. So in the first case, we're going to just add 2 to both sides. Now we're looking at 5x is less than or equal to 10. And then let's go ahead and divide both sides by 5. So we get x is less than or equal to 2. And then in our other inequality, we're going to subtract 9 from both sides. So we're looking at 6x is greater than or equal to -6, and divide both sides by +6. So no inequality flipping, because we're not dividing or multiplying by a negative. So we get x is greater than or equal to -1. Now let's draw out our number line from -infinity to +infinity. And we're looking at, we'll put maybe -3, -2, -1, 0, 1, 2, 3. And so first, let's graph. I'm actually going to create 2 copies of this. I'm going to need the other one in a second. Let's graph our yellow highlight. X is less than or equal to -2 or to +2. So at 2, it's less than or equal to, so we're going to fill in that circle and we're going to shade all values less. So this is our yellow. And then our blue, we're going to look at -1. Fill in that circle, and we're looking at all values that are greater than or equal. So we're going to shade to the right. And that's going to be colored in blue. And again, our end stands for the overlap. So yellow plus blue creates green. The green is our solution. So if we were to graph the green down here, we would get all values from -1 up to +2. And so in interval notation, that's just hard bracket -1, comma, +2, hard bracket. And we're done. Right. There's a reason why I use yellow and green, right? Our primary colors, you combine the paint and you get green. And the green is what we're looking at. Right. Questions on this problem? Okay. Let's move on to question 13, which is on page 7. We have a systems of equations problem. So they don't specify to use elimination or substitution, so you have the liberty to use your preference. And then it says write your answer as a coordinate point if possible. If there's no solution, then just write no solution. So I'm going to use substitution here. And I'm going to take that second one and actually just add, well, actually, ooh, I do love substitution, but elimination is staring at me. Right, the 4y and the -4y. Yeah, let's do elimination. So we're just going to add the top and bottom. And so we get 4x is equal to 4y minus 4y cancels out, and then 10 plus -2 gives you 8. Oh yeah, so happy I did elimination. Because then we just get x is equal to 2. And now we can plug this into either of the equations to solve for our y. I'll just use the top one. So 3 times 2 plus 4y equals 10. 6 plus 4y equals 10. 10 minus 6 gives you 4. And then 4 divided by 4 gives you 1. So your y is equal to 1. So in coordinate point form, we get our solution to be 2, 1. And let's check to see if that works. 2 times 3 is 6. 4 times 1 is 4. 6 plus 4 is 10. Good. 2 minus 4 times 1 is 4. 2 minus 4 gives you -2. Excellent. Questions on this so far? No. You guys are doing amazing. All right, let's move on to question 14. We have simplify the expression below and eliminate any negative exponents. Assume that x and y are positive numbers. Right? So first step is I'm going to distribute that -4 or -1/4 exponent in to each of my either coefficients or the exponents. I'm going to distribute it 4 different times. And so we're looking at 8 times -1/4 is just -8/4, because when you raise something, you're multiplying the exponents. Then we have y to the -4 times 1/4 is y to the +4/4, right? Because -4 is the same as -4/1. 8 is the same as 8/1. All divided by, then we have 16 to the -1/4 power. And then we have y to the 4 times -1 is -4, and 3 times 4 is 12. So we get -4/12. Let's do some simplifying. -8/4 is just -2. 4/4 is just 1. 16 to the -1/4 is the same as, well, we'll keep it as 16 to the -1/4 right now. Talk about that in a moment. And then y to the -4/12 is the same as y to the -1/3. Okay. Now, if you see the negatives in your exponents, you can move them to the other side of the fraction and make them positive. So these guys, maybe I'll highlight them in green, will move up to the numerator to be positive. And then this guy up here will move down to the denominator to be positive. So we can rewrite this now as we have 16 to the +1/4 in the numerator. Then we have y to the first stays in the numerator, but now we also have a y to the +1/3 in the numerator. And then in our denominator, we only have x to the +2. And now we can simplify that 16 to the 1/4. That's just what is the 4th root of 16. That's another way of stating it. What times what times what times what gives you 16? 2. And then that y to the first times y to the 1/3, when you are multiplying terms that have the same base, what are you doing to the exponents? You're adding them. So this is the same as 1 plus 1/3, which is just 1 and 1/3. And that's just 4/3. And then we have this x squared. So we can write it as 2y to the 4/3 all over x squared for your final result. If you wanted to put it in terms of root form, you could write it as 2 the cube root of y to the 4th over x squared. Or if you wanted to take out one of the y to the thirds, you can write it as 2y times the cube root of y all over x squared. A lot of different variations that would yield you a correct result. Sorry. All right, questions? No. Let's go ahead and move on to question 15. We have the graph of y is equal to f of x is given below. Use the graph to answer the following questions. They also like to put a question like this on the final exam. It tells us that you guys know how to read graphs properly and you're not intimidated by the pi symbols. So part A is asking to solve f of x is equal to -4. This -4 is your output value, your y. So when y is -4, what is your x? So go to -4 on your y-axis, go down to figure out what your points are, and they even give you the coordinates. So you're just looking at your x values here. Your two solutions are pi and 3 pi, and you can separate it by a comma. So we get pi, comma, 3 pi. Part B is asking for the domain of this function. So domain, all of our possible x values. So we look at our x-axis and we ask ourselves, what is the smallest x value possible? And what is the largest x value possible? And we're including those 2 points, so we're going to have hard brackets at 0, 4 pi. And that's it. Question C is asking for the range. So now we're going to go over to our y-axis, and we want to look for what is the smallest y value possible, and what is the largest y value possible. And because these are points on our function, we are including those values. So once again, hard bracket, -4, +4. Good so far? I think there's a few more, or no? Nope. Yeah, that was all of question 15. So now we're going to move to page 9, where we're looking at question 16. We're asked to find the x-intercepts of the graph of this equation, and then we want to write our answer in coordinate point form. So we know definition of y-intercept is when x equals 0. What's the definition of x-intercept? Yeah, when y equals 0. So if this is our equation, we just want to sub in 0 for y and then solve for x. So we have 9x squared plus 4 in parentheses 0 is equal to 36. This shoots to 0, so now we're just looking at 9x squared equals 36. Divide both sides by 9. And so we have x squared is equal to 4. Take the square root of both sides, and you get x is equal to plus or minus 2. So in coordinate point form, we're looking at, these are x-intercepts, so negative 2, comma 0, and positive 2, comma 0, and we're done. Let's move on to question 17, where they're asking us to use the quadratic formula to solve the quadratic equation.
Can you go up for a second?
Yeah, of course. Yeah, any questions on this one? Okay, good. Okay, cool. Question 17, quadratic formula. So remember, pop goes the weasel. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And now let's identify our a, b, and c's from the equation that they give us. Our a is 3. Our b is negative 5. And our c is positive 1. Let's plug in. So we get x is equal to negative b. Well, negative times negative 5 gives you positive 5, plus or minus the square root of negative 5 in parentheses squared, minus 4 times a times c, all over 2 times 3. Negative 5 squared is 25. 3 times 1 is 3, times negative 4 is negative 12. 2 times 3 is 6. 25 minus 12 is 13. And so you end up with x equals 5 plus or minus square root of 13 over 6. And that's already in simplest form. You can't simplify that further. Right. On a scale of 1 to 5, how do you guys feel about quadratic formula at this point? Nice. All right, cool. Let's move on to page 10, question 18. We have solve the radical equation, square root of 2x plus 1 equals x for x. Remember to check your work. So they already have, I don't know, I was like, they have x already isolated, but they don't. I didn't see this other x. So what do we want to do? We want to get all of the x's on one side. First, we need to get rid of that square root. So we're going to actually have to subtract 1 from both sides to get the square root all alone, so that we can square both sides to get rid of the square root. So now we're looking at 2x plus 1 on that left-hand side is equal to x minus 1 in parentheses squared. You could do FOIL off to the side, but also we're looking at a perfect square trinomial. That's just going to give us x squared minus 2x plus 1. And then now we're in our quadratic world. Let's bring all terms over to that right-hand side, because that's what we do when we're dealing with second-degree polynomials. And so the ones actually end up canceling out. So we're just looking at x squared minus 4x is equal to 0. Let's pull out a greatest common factor. We can pull out x, and then we're left with x minus 4. This is all equal to 0, which tells us that our two tentative solutions by zero product property are x is equal to 0 and x is equal to 4. However, we need to check to make sure that both of them work. So if we plug in 0, 2 times 0 is 0, plus 1, square root of 1 is 1. 1 plus 1 is 2. Does 2 equal 0? No, so we have an extraneous solution here. Now let's check for 4. 2 times 4 is 8. 8 plus 1 is 9. Square root of 9 is 3. 3 plus 1, does that give us 4? It does. So therefore, our only solution for x is equal to 4. So for x is x equals 4. Sometimes they put extraneous solutions on the exam, sometimes they don't. But regardless, that's why it's so important to check your work. Whoever made this exam was nice. They wrote, remember to check your work. That's a hint in saying there might be an extraneous solution. Okay. Almost there. Let's move on to question 19. We have performed the indicated operation and simplify. We're back to just good old adding fractions and looking for a least common denominator. Now, our LCD, let's just review our knowledge of cake method, even though you guys probably know what the LCD is at this point. You look at the denominators, 10 and 15. What can you pull out? A 5. 5 goes into 10 2 times. 5 goes into 15 3. Are 2 and 3 relatively prime? They are indeed, which tells us that our LCD, also known as our least common multiple, is the product of 5, 2, and 3, which gives us 30. Now we're going to rewrite our fractions. And that first fraction we are going to multiply by, 3 over 3. Our second one we're going to multiply by, excellent. So now the denominator is 30. We can bunch it up into one fraction. 3 times negative 3 is negative 9. 4 times 2 is 8. Negative 9 plus 8 gives you, so our final answer is negative 1/30. Let's move on to question 20. Slope question. We're given 2 points, point P and Q, and they lie on line L, and we just want to find the slope. So our formula for slope when we're given 2 points, sorry, delta y over delta x, or y2 minus y1 over x2 minus x1. We're going to label our point P as x1, y1, and our point Q as x2, y2. So when we sub in our numbers, we're just looking at -1 minus 4, all divided by 2 minus -3. 2 negatives next to each other give you a positive. -1 minus 4 is a -5. 2 plus 3 is a +5. -5 divided by +5 gives you -1. So our slope is just -1. That was part A. Now part B is asking us to find an equation of a line of line L and to write it in our slope-intercept form. So we're going to have to utilize our point slope form first. I'm going to write part A's result. Our slope is equal to -1. And they don't give us the y-intercept, so yeah, we need to use point slope form in order to convert it into slope-intercept. And so recall, your point slope formula is just y minus y1 is equal to m in parentheses x minus x1. Does not matter which point you use. I'm just going to use -3, 4. So P is -3, 4. We'll let that be our x1, y1 here. And so if we color code, we have our x1, we have our y1, and then we have our slope. So when we plug in, we get y minus 4 is equal to -1 in parentheses x minus -3. 2 negatives next to each other give you a positive. So we have y minus 4 is equal to -1 x plus 3. If they said to keep it into point slope form, this would be your answer. But they want you to put it into slope-intercept, so we need to distribute and get our y all by itself. So we get -1x minus 3, and then add 4 to both sides, so that we get y is equal to -1x plus 1. So now it's in our y equals mx plus b. And we're done with part B. We have like 3 more pages. So let's move on to our page 12, part C, which is saying, okay, now we're going to graph this line. So I'm actually going to bring over my slope, bring over my slope-intercept form, bring over my point P. And then I'm also going to bring over point Q as 2, -1. So I'll write that down too. That's 2, -1, right? Yeah. Anytime you have questions that have A, B, C, D, E, it's to work in your favor. You use your earlier letters to help you with the later letter problems, okay? And so all this stuff, we can plot both P and Q straight off the bat. Let's first put in our proper template. Let's label our X and Y axes, our origin. We're going to put in a proper scale, go up by ones. I want to say like 98% of the time, you're going to be going up by ones. Right, that's all done. Let's plot both Q and P. So P is -3, 4. We have Q is 2, -1. And then we can plot a few based off of our slope. So from our slope is -1, so it's going down from left to right. So let's go down 1 over 1. We can plot a few points. Got a y-intercept, x-intercept in there. Now we're just going to connect the dots. Draw our arrows at the end of our line because lines go on forever. Label our line, y is equal to -1x plus 1. And this is our line L, right? It says graph line L. And that's it. That would yield you full credit for the graphing portion. Part D is asking what are the x and y intercepts, but lucky for us, we already graphed our y-intercept and our x-intercept, so we just have to look at our graph and write our points. Our x-intercept is at 1, 0, and our y-intercept is at 0, 1. So we don't have to do any math here, we just have to look. And then part E, which I believe is the last part for this question, is the line x minus y equal to 8 parallel to line L? If yes, write yes and explain why. If no, write no and explain why. And keep your explanation brief. So I'm going to once again bring down my current equation, and I'm comparing this to what they give me, this whole x minus y is equal to 8. Definition of parallel means we need to have what? Yeah, we need to have the same slope. Same slope, but different y-intercepts. So again, our line, our slope is -1. If we can get our slope to be -1 for this guy, then we're good to go. Let's isolate our y. I'm going to add y to both sides and then subtract 8. So I'm looking at y is equal to x minus 8, which tells me that my slope here is what? Yeah. So are these the same? Therefore, these lines are not parallel to one another. This is just the short script for parallel. Because the slopes are different. Or the slopes are not the same. And that's it. One more question, guys. Powering through. Question 21, right? Lo and behold, we have our quadratic function problem, which there's a good chance this is going to be the last question on your final exam. So if you are a little bit nervous, but you know your quadratic functions, then once you get the exam in your hand on Friday, you should just skip to question 21, solve it, and then you don't have to worry about that for the rest of the test. Okay, so we're given negative x squared plus 6x minus 5. That's our quadratic function. First part is just asking, does this open upward or downward? Downward, right? Our a value is equal to -1, which is less than 0. So it fans down. Oh, you guys just got a point. Now let's find the axis of symmetry. What's our formula for axis of symmetry? Good. What is our a value here? And what's our b value?
6.
Good. So now let's plug it in and we get -6 over 2 times -1, which ends up giving us a +3. So x is equal to 3. Just got ourselves 2 more points. Now let's find the vertex. So we use part B to find the vertex. Our function f of x is equal to -x squared plus 6x minus 5. If we want to find the vertex, we're just plugging in 3, our axis of symmetry, to find our y-coordinate point, which is the y-coordinate point for our vertex. So we get 3 squared is 9, the negative is brought down, 6 times 3 is 18. -9 minus 5 is -14, plus 18 is a +4. So in coordinate point form, our vertex is just 3, +4. I'm going to bring some of this information over the next slide. We're definitely going to need it for the graphing. And then we'll bring the a down as well. Their axis of symmetry. All right. So part D is asking us to find the x and y intercepts of our function. Definition of y-intercept is when x is equal to 0. Definition of x-intercept is when Wait, definition of y-intercept is when x equals 0. Definition of x-intercept is when y equals 0. So y-intercept is nice and straightforward. What do we get? 0, -5. It's always just your c value. X-intercept requires a little bit more work. We set our function equal to 0 and then see if we can factor it. I'm going to bring everything to the right-hand side. So I'm looking at positive x squared minus 6x plus 5 equals 0. So that factor pairs of 5 that add to -6 is just -5 and -1. And so our two x-intercepts are at 1 and 5. In coordinate point form, that's just 1, 0 and 5, 0. Bring this guy down. And this one down. I'll actually bring those also down here. So that our final question is just bringing A, B, C, and D all together. So x-intercepts, y-intercept. Where we want to sketch the graph of this function. And then they are asking us to also label vertex, zeros, and intercepts on the graph. So a lot of labeling. Before we even start graphing, let's label our x and y axes, label the origin, put in a proper scale, just think, after you take the final, you don't have to, well, you guys are probably all taking pre-calculus. After pre-calculus, you don't have to label this ever again, unless you're in engineering or you're a math major. I have to do this for the rest of my life. You know how many times I've labeled graphs? A lot. Right? Let's plug in our vertex. We have 3, 4. We know it's going to fan down, so we're going to have some nice space up here. I'm just going to label this vertex and write that coordinate point down. For those who came in a little late today, again, I'm not going to be grading. I'm only grading like 2 or 3 questions out of your entire final exam. And the professors are very strict. A lot of them take almost all points off for graphs. If you're not labeling it vertex with the coordinate point, you get points off. If you don't label your x and y axis and put it in a proper scale, points off. If you're not putting the labels on the graph, you'll get points off because a lot of professors only have this box cut out on their grading platform, and so they don't see any of this stuff. All right, let's plug in our x-intercepts. We have 1, 0. We have 5, 0. This is 1 x-intercept. 1 comma 0. This is the other x-intercept. 5 comma 0. Make sure you're neat. You can read your handwriting. 0 comma negative 5. This is your y-intercept. Now they don't ask you to put in your axis of symmetry, but I personally like to put it in because then I can reflect the y-intercept point quite easily. I think when I scanned it in, it was slightly off. Yeah, bless you. So we have x is equal to 3. This is our axis of symmetry, which means when we reflect that y-intercept 1, 2, 3 units, we have 1, 2, 3. Plot that point. And now we can just connect everything. So it's a nice parabola, so an upside down U. Make sure you're putting in arrows at the end. And last but not least, you want to label your function. So we have f of x is equal to negative x squared plus 6x minus 5. And that's it. That completes this question and the entirety of this sample final exam C.